As you can see on my screen now, this webinar is actually for our engineers. So I will be showing you the new features of Allplan 2024, especially for engineering. And then, but before I start with, for those who have missed the webinar previously, the recordings are available in the YouTube channel, in our YouTube channel, and of course we're also sending some emails for you to look back on the webinar that we have done previously. So let's start. For my presentation, so just to give you an overview about myself, so I'm Jason Panganiban, a technical specialist of GSI for precast. So basically, I'm a licensed engineer with almost 13 years of experience in using the Allplan software, and then also handled some projects in Singapore. So most of the projects that I handled are all precast. So moving forward to the agenda, what we are going to highlight today is about for structural framing. So we will do a structural steel frame model. And then after that, we will going to follow with automated connection. So this automated connection comes from SDS2. And then we're going to, I'm going to show you also the reinforcement, enhancement for the reinforcements. We have the improvements on the rebar on the 3D view, and also some improvements on the column automatic reinforcement, and then also we have the reinforcement for the wall, especially for the connections, for the in situ area. And then we will also discuss a little bit on the clash detection attributes, which I think is also be useful for your reference. And then the last will be for those who have the mesh welding system on their factory. Then this I can really highlight to you the things that improved on this mesh welding system. Okay, so we go now for the demo, and then let me just change my sharing screen. Okay, so for those who haven't been seen the Allplan interface, so we have this just to give you some overview on what you can see. So of course we have normally the normal window for the plan view, for the isometric view, and for the 3D render view or animation view. And of course we have also this different solution in Allplan. So for your information, we have different solutions in one software. We can have the architecture, we have the engineering, also have the surroundings, the normal drafting, and then we have also for the bridge, and then also have the precast for the precast elements, wood construction, and then we have the construction. So basically, we have these tower cranes, we have these utilities on the construction. And just to give you some of the bridge, so we have this functionality directly with Allplan connected. So yes, so that's why we have we can say that Allplan has a solution that suits your needs on your construction. So basically, we will go to the engineering, which is our topic today. So if I just go now to, so our first topic is actually the creation of structural steel frame. So what is the new on this feature? So now we have this new features here. So actually the icons are, we have the grid, we have the column, beam, we have the bracing and connection toolbox, and then these automated connections where we will discuss later after we have done the structural framing model. And then of course, so as you can see here on my screen now, I have this grid. So it came from this axis grid. So how to use this? It's just a matter of just setting all your informations. So as you can see here, so I can just place it there. So here you can see that I don't have the z-axis line. So if I want to just activate this, and you can see there's an z-axis line. Okay, so I can just delete this one. So moving forward, maybe I can just put something here. So I just prepared some predefined footing just to make the presentation more complete. Okay, so now we can start with the column. So from the column, we just click this column, and then you can define if it's just a rectangle, a circle, or of course, there's a library. So from the library, you can just select on these types of libraries. So if I go to our Nemetschek profile catalog, we have different sets of profiles here. There are some more. You can just load them from the uh, Nemetschek profile catalog, and then you can have it on your library palette. So here you can have different profiles depending on your locations, of course. So let's just use what I have here. Okay, and then here we can define if it's just vertical or it will be inclined. So when you say inclined, of course, you can define the starting and the ending point. If it's just a straight line, so you can just define a straight line. And then here, of course, Allplan is plane based. So basically, it will carry out the planes that you have set on your plane setting, of course. So just to show you, I have set this kind of planes levels. Okay, so in other words, it's just the level of the structure. So we can just define, and then these properties will be basing on this the set plane level. Okay, so just to go through, we have this references point. So wherever you want to start, you can just point it, click it, middle. Okay, and then this one also you can use the reference point in the center of the gravity. So of course all the elements has this CG. So if you want to set it on that point, then you can just activate this. Okay. Then what else? Representation. So these are just for the real representation of column. And if you have some attributes here, you can define also. But basically, we just use the default here. So I can say from here, I can click, and then as you can see, I just placed on that point, and I have my column. So technically, I want my column to be on this level only, which is at the level 5,700, at the height of 5,700. So what I can do is I can just say double click on the element and then define from here, and then say I want to be from this structure to make it on this structure, and then I will say just 0, and then as you can see, it goes to this level. So again, the plane levels are very important when you place this elements. Okay, so to continue, I have already placed one, so I can just say either I copy this from here to here, just selecting, or I can work with this also, no problem. I can work with this 3D. As you can see, wherever I go, it goes to the same location. So, oops, I picked the wrong one, so I can just place the correct one here. or from here. Okay, am I selecting? Yeah. Okay, so what I need to do now is I just have to delete this excess. So I have my two columns, and I want to provide also another one at the middle. So just say click on this, and I will just say, okay. So by the way, before I forgot, from this setting, you can also define your favorite. So if let's say this will be used many times, so you can just define, let's say save this profile and then put it on your preferred location. And then you will just have to load it, select from this folder, and then you can say, click on this, and I will have my middle column. So let's say, oh, okay. So this should be my first column. I can define it. So this is my second column. Okay, so let's say I put it here. So again, my level was based on the plane. So this one is on the top. So I just changed it from the 6,000 to 6,000, I mean. And then of course, I want this profile to make it bigger. Of course, we can just say double click on this and I will load my favorite. So instead of 152 by 22.5, I will just use this column, which I preset, and it will be at 200 by 26.6. So of course, all of this coming from our Nemetschek catalog. Okay, so I will just say close, and you can see it already changed. So I can do the same thing here. Just double click on the element and then load this one and then say okay. So now it is changed to 200. Okay, so just to continue, so now we already have our column. So what we can do next is for the beam. Okay, for the beam, we just click on this and then of course we have the same setting. Okay, for the same setting, then of course defining what type of beam you're going to use. So for this case, I can use my predefined already. It is just the beam at the, let's say at the mid level. So why I said mid level, so I have agreed on this level, which is I think 3,000. So let's see if I can use this and let's define. So I defined that level as the 3,000 and make that one in a zero offset. So when I placed even on the plane, on the plan, I mean, I placed my beam or I click on this area. So as you can see, it goes directly to my 3,000 elevation. So I can just define from here to here. Okay, and then another from here to here. So as you can see, I have defined this elevation easily. So what's next? Okay, so basically I want to provide some sloping beam here. So, okay, we can use the same. You can just double click on this, double right click. So it will give you the same feature, or you can just do right click and then say match, then it will open the same thing. So from there, we can say that instead of using the straight or horizontal, I will have to use the inclined. So when I say inclined, as you can see here, I have two options already. So here you have to define your the bottom level, and then the next is your top level. So for this case, I need to change this to a 6,000 level. And then from the bottom, I need to use this as the 5,700 level. So it means I will put my beam from this point to this point. Okay, so, or you can also use this part. It's no problem. So we can just still define the same thing and then say, okay, and then let's pick on this point. Oh, because I did not change this, right? Okay, so basically I need to, so click on this and then say click because we have activated this, so we can define this as from here. So as you can see, it's on that level, and just define it also here. So we just have to select the correct point. Okay, so it's now a sloping beam. And then of course, you just define. So for the inclined or sloping beam, sometimes this is not useful much, but of course, it's better to set it correctly. So as you can see from here, I think, yeah. Okay, so I just have to select this, and then another will be, should be something here. But I guess once you click it, it will not overwrite what you have clicked. So basically, you can just use your clicking points. So yeah. So now I have this frame now. Okay. So basically, the modeling wise is all the same for, I can say, for other softwares, but it is actually, I can say this is all useful for your, if you're using one solution like Allplan, so you will have everything. So you can combine all the all the informations from architectural to engineering, and then for your construction as well. Okay, so to continue, I will just have to make these things complete. So I will just have to say copy. Yeah, copy, and then I select the whole thing. So I just have to define my first point where I want to be my reference point. So from here, and I want to copy it 2 times. So I just go to my number of copies, say 2, enter, and then I can just click on this. Then I will have my copied structural frame. Okay. So to continue, just to make it more complete, I can just say double click on this and then define the points again. So I can do anywhere. I can click here or click on this side. So define the point, and then I can of course say copy again from here, then define my reference point even from here, and then say two numbers, and then to here. So I can have that. Repeat the same process with this beams. So I can click, not the grid, but the beam, beam, and beam. And then say from this point, I can put also my distance directly. So say, okay. Now on the upper part here, so we can do the same. We can say that I can use this beam and then define the level. So instead from this, I will go to this level and say okay. And then I can click from this point. So as you can see, it goes on that correct level. Another from here to there. Let's see. Okay, and then I can do a copy again. Just see, copy, and then from here 4,000, and then see, click copy again the other side, or you can use also mirror. So these are just basic commands. So we can do a mirror without a copy or with a copy mirror. So we select these objects. You can select multiple, just right click, and then you can see there's a summation icon. Then you can select multiple elements and then say okay, and then click, or yeah, you can click at the middle of this. Make sure you're clicking on the correct reference. So as you can see, it goes to the other side. Or I can also do another beam for this portion. So make it complete again. I can use this, right click, double click, and then define again. So from here, I will just use my 6,000, which is the level of this top portion. Then I can define from here. Make sure you're selecting the correct point. From here to there. and another is from here to there. So again, even you're selecting on the plan view, since you provided the level, so it will go to the correct levels, as you can see from here. Okay, so now we're almost done with the frame, and then we can provide also the horizontal bracing here. So what we can do is we can use this brace. Okay, so here I already defined what profile I'm going to use, or I can also load from my library and say this one. So actually they are the same. And again, we need to consider this level. So I want to put the bracing at this 3000 level with the 75 offset from the top. So I have to define this, the 3000 level, and then minus 75. So again, if I just click on this point, so as you can see, it goes directly on that level, and I can just click another on the plan view, which is easier to select, and then you can have your beam or your bracing there. Another thing is on this one, so we have to you have to provide, did I select the correct point? It has to be the correct point, so we should select this and then define it from, let's say, you cannot go directly there because there should be a connection here. So I will just define 45-degree. I just cut it from there and then continue, click, and then click again. Okay. So for this case, I have now my bracing. Okay. I'm thinking also maybe I can provide some secondary beams here, so I can also provide that using the same property, or maybe I can use my property here for the secondary beam. So this changed my profile, which is the one UB152 by 89 by 16, and then the level will just predefine here. So I can just select, let's say from this point, let's say, or maybe I can define it properly. Let's see, since I provide the 5.7, okay, and then this one is correct, yeah, 5.7, and then here we'll define also 6,000 because I need to define it on that. So let's see, it's correct, yep. And then, so again, if you are clicking the incline, I think it will still give you on the, you see it's still on the reference point, so just to show you, so it still goes down. So what I can do is that I can define also from this point. So I did not click. I can just go to my z-axis and then say 5007. And of course, I want to put it on my x-axis to make it, let's say, 2000. So as you can see, 57. Did I click it correctly? Again, let's try. Okay, so I have to make sure everything should be correct. Or we can so actually we can select from here, from this point. So I can say my x-axis to be 2000. So it goes there. So you don't have to really how to say it, you don't have to really go down. You can define from that point, and of course from here you can say that from this point my, okay, so I can define again my 6,000 height. So as you can see, I placed my beam there. So I can copy this, copy another, just define to 4,000, and then I can do mirror with copy, select, and then select my midpoint. So I can click from this point and I can just say this is my axis of mirror. So I just define it. So now I have this, my secondary beam, of course, my um, horizontal bracing and other things. So this is actually your frame. Okay, so moving on. If you have questions, you can ask me through the Q&A box. Okay, or maybe I can add some more. I can add another horizontal frame, so make it more information. So I can say copy, select this braces, and then just move another 4,000. So I can have another on the side. Great. So I have this now. And let's say I want now to go to my automated connection, which coming from SDS2. So this is a new feature. So just to give you about this, Allplan has a connection with SDS2. So for this case, all the connection was based on the standard of SDS2. So if you are not familiar with SDS2, SDS2 is the detailing software for structural steels with the connection automatically. And of course, you can also consider the loadings directly on each profile or elements that you're going to use. So basically, when I just click on this automated connection, so you can see this SDS2 by Allplan. So if you want to get more detailed information of the elements, the connection of this, the plates, the bolts, the welding points, you can use SDS2 for your deeper detailing of structural elements. So now what I'm going to do is I just have to select all my structures, and then you can just wait for a while. So of course, the system will have to detect all the points that is necessary to provide the connection automatically. So it is defining all these frame horizontals, and as you can see, with this a matter of seconds, you can see that there's a predefined connection for our steel frames. Okay, so you can see here I have already defined, and if I just press one escape, so it will actualize already the connection that suggested by SDS2 in this structural frame. So if we look deeper, so you can see this is our just suggested connection based on SDS2. So you can have this connection also for your bracing. Then if we're looking for the column, for the connection of the column, for the base plate, of course, we have this library, and then I can go to my default. We have the Python part, and then we can go to structural framing. So this automated connection here is actually the same of this, and then we can have this base plate. I will just have to double click on this, and you can see this um, palette for the base plate. So as you can see, I have this different um, profile. So let's say the rectangle or the circle, and then you can define also if it's automatic or default. You can define the offset, so you can see with number one will be this one. Then you can have the bolt information, you can have the weld parameters, and then you can just have your also stiffener if you wanted to. So for this case, let me try to create use the default. So whatever here. So I have the offset of 100 and then the thickness of 12. So I can just define it from here. Just select your column actually, and then you can see that I will have my column, my base plate for the column when I close this. So I have defined already my base plate. Another is you can just select again by continue selecting, then close. You can have all this information of the base plate. So just click and then close. Okay, so of course, since they are Python parts, of course, you can also copy them. Copy from this, since this this one is the same as this one, and then these two are the same all throughout. So I can say just copy all, because of course the offset is considering the overall dimension of the column. So you cannot just copy one and then copy to all. So of course you need to copy those similar parts or similar elements. So from here I can say this one. Did I select the correct path? Okay, this one. Sorry, I have to select the whole thing. Say copy, and then select this, and then I can select. I can just copy from here. Let's say 2 times of 4,000. So I can have my base plate all over this structure. Okay, so this is the topic for automated connection from SDS2. I can go now to a bigger structure. So maybe you will think of how long will it take for Allplan to generate the connection of each of the elements here. So maybe we can start now by selecting this, or maybe I can just hide first the grid so that it will be easier to see. I don't want to see my grid. So we have this object palette wherein I can just say select my grid, and then you can see it here. I can just say hide it. Okay, now we try to select this, and then we hover the whole structure. And let's see how long it will take. Of course, there's a lot of profiles, a lot of connections. So the system will have to really go deeper to see all the connections possible from SDS2. So it will take about a minute, maybe a minute to recognize all those things. Yeah, so if you have questions regarding the topics, you can just place in your questions on the Q&A box, and then we will try to answer those if we have still some time. Or if not, we will send you an email corresponding to your questions, the answer to your questions. Okay, so now we started at 10:33. Now it's 34. So let's see. It's around 1 minute. And again, these are not just one or two or three points. There are different points considered. There's also a splice in between the column. So we can see that later. Okay, so it's defining it. So okay, so just to give you, we have all the recordings of the past webinars. So if you are interested on any topics from our webinar, so you can just visit our um, LinkedIn page or LinkedIn account, the GSI group, and also the Allplan Asia Pacific in LinkedIn. And okay, now it's done. So as you can see, all the points are detected, and there's already predefined connection even for this splice. So I will just have to, so will this take a little bit time. So I'll just have to press escape to actualize the connections suggested by SDS2 to Allplan. So this will take just a few seconds or another minute. So basically, from that initial stage, it takes about 1 minute for all those points to be determined, or more than 1 minute, but not more than 2 minutes. So it's just a matter of just defining all the points. If it's correct, then you can just say escape, and then it will actualize it. So of course, this is area one, so it will take another minute maybe to actualize the whole information. Okay, great. So if you have questions again, you just type in on the Q&A box so that I can answer some of your questions while waiting for this to actualize the whole information of the connections. Okay, so you need you need some time again to actualize it. So don't worry, it's still loading. And again, it's not just 1 point or 2 points. There's a lot of points as what you see earlier. So this, I think, will take a little longer, but not that long. And considering this kind of structure, I'm sure um, everything will have to be considered. Like, for example, you can see from this cut, there's a cut here. They are already considering the cuts also. So now it's loading 41%. So maybe the cuts already defined, and now it's defined. And as what we can see here, the bolts and also the splice are defined. So again, these connections are predefined by SDS2 in Allplan. So you see, all the connections, all the points were covered from this connection. Okay, that's all for the structural framing. So we move now with reinforcement, and then let's change my file to this. So from this part, we have different kinds of column. We call this column status, or what you call this situations. So I will just have to change this to 3D. Okay. So I have the column on top with the and the beam at the middle. I have column on with a slab. So I have also just a column for this will be for your links later. This is the column with a slab again, but using the starter bar. And then of course, another situation is the column, the slab, and then we need to provide the lapping. But this case, the column are different in different size. So we start with this beam, column, beam, or sorry, column, beam, column. So we go now to our, I can go to engineering structure here. So basically, I will just go a little bit faster because of the timing, but let's make it more still interesting. So I have now the two columns with the same profile, the same size and the beam. So at the beam, we'll just need to change the transparency so you can see properly. So let's say from here. Okay, did I correct? Did I say correct? Okay, so I cancel maybe. So I say okay, and then I can have it here and also here. So there's some graphical problem here, but you just have to refresh and it will be something like this. So you have this links at the middle. So what I can do here is we go now to our automated column reinforcement, and here we have this property. So what I can do is, let's say I have this settings. So of course I need to define first my column below. So I just have to select column, and just so you can see, I have this settings here. So let's just load the original one. So from here, I have my crank, wherein I can set that one from here. So from the main rebar, I can set if it's crank or overlap, and also for the sidebar and the corner. So you can define from here. And then, of course, if you stirrup, you want to change some stirrup informations and also the sections, then you can define from here. So basically, this is general information of the reinforcement and the column. So you have the 25 cover with the concrete grade and then also the bar grade. Then here you have the diameter information of the bar. So for this case, I would just use the original setup. I will close this. Oh, sorry. It should not be closed, but instead it should be the from the workflow you have to create it. Okay, so now I have this setting. So this is basically what you said. So what is the importance of this? If I have this clash detection and then select this part, so as you can see, there's a 6 clashes on this part. So I have this clashing. So from here, I can say that I have to avoid the clashing here. So what I can do is that I will just say, would you like to save? So I can save. Yeah. So you can see there's a clashing indication here. So what I need to do is just double click on this and then modify. So if I go to my rebar, main rebar, let's say offset a crank about 500. Here also maybe about 500, just an offset for the crank. And then say close. I want to change the parameter. Do you want to update? Yes. So I still have the clash there, but let's delete it first because that was from the first checking of the clashing. So I need to, let's say, select my type of clash and just over everything. So now I can do the clashing again, clash detection, and then select this part. If you can have this, you still have the 10 now 10 clashes. So it means you have to define it correctly. So to make it faster, I have defined it, predefined it. So let's go to my load. So again, we have this load folder, and then we can have this setting, and then say close, say yes. And then let's see if I still have my clash on that area. So there are no more clash. So this is how effective your clash check also for your structure. Okay, so that's for this part. We move now to the column slab. So for this, we can define again this column. And then from here, I can say I don't have a column on top, so I can just select this. And as you can see, I need to crank those top bars. So just to make the thing short, I already predefined this. And then this one is the slab column. So as you can see, it has the setting here. So that setting is coming from here. Okay, so you can just define from there and then say close. Oh, sorry, not close again, but you need to select the create. So it will actualize it. Okay, so that's how you can use this. So of course, we can check if there's some clashing on this part. So let's try select, and then the clashing actually goes into the column and not on this part. So there's no red here. So all of the clashing are there. So you can change some information. Maybe a clashing of this part, or yeah. So you can check on this. Next, we now go now to the column with the link. So what is the new from this link? I will just have to select this and say click the column. So I don't care whatever it is. So what I'm concerned about is the stirrup. So you can define how many stirrup you want. So you can have it like 2. Then you can have this, let's say, add more of the link. So you have 2. One is the hook, one is stirrup closed. So you can define it from here. And then, of course, the diameters will be defined. So this is the diameter. And then once everything's fine, let's say, you can just go back to workflow and then create. So you can have both the links, closed links. So if I go to this one, you can see it here. So you have this option. So moving forward, within the column and slab again, but this one with the starter. So again, I can just say select this one with the same icon, select the column, And then from here, I will just have to define my preset. So this one. So what is the change here? So basically it's the starter, this part. So initially it's the main bars are cranked, but this one is you're providing the starter. So it is something like this side, this part. So from here, you can say select the main bar as the hook. That's the first one that I've shown. And then we select the hook starter bar. So that's why you have this. So you can define if you want your main bars to be stopping at the column only, and then you will provide the starter bars to anchor on the slab. And then if that's correct, then you say create. Okay, and then now we move, sorry, we're going to be fast because of the timing. But yeah, so just to show you different information about this column. So basically I can just select this again. So I have a column on top, so it has to be this one and then select this one. So you can see here, I have different size of column and it can detect it. So basically I need to create this kind of links to attach to the new profile or the size of the column on top. So basically I can just load what I have created, and then let's see, where is it? Column starter lapping. So this is the one. And as you can see, I defined just changed some of the bars numbers. So that was changed from here, of course. So you have more information below. What are the lapping lengths? What are the diameter of the bars that you need to provide? And then if that is already fine with you and the correct detail, then you just go to workflow and then say create. Okay, so moving forward now, this is for the column. These are the new features of column. Then we go now with um, what do you call this? Oh, by the way, before I forgot, so the new enhancement also for the TD model. So before we cannot select the reinforcement, but now on the 2024 we can define or select the element, and then from there we can change the diameter of the bars. We can automatically change or we can define, let's say, the spacing of the bars that you selected. So now we can easily define it directly from the 3D model. So that's another improvement. So we go now to the wall. So we go to the wall, this one. Okay, so from here, so what is the new in the walls property or automatic reinforcement for wall? So we have this automated wall connection. So we can say what connection we want. So let's say a Python part, and then let's say, for example, this part. So as you can see, it automatically gives you the connection on the corner part or on these two walls. So you can just say close and you will have that connection. You can select multiple. Sorry, of course, you need to select the icon first and then you select multiple connection. Oh, there are some two walls. Okay, so let's see these two. Okay, between two walls. Okay, okay. So I can select, let's say, for this one, because this it has to be defined only just the two walls. Okay, so this one you can see that I have defined this, and there's a number 1 and 2 for the walls. So it basically has to select only two walls to define your connection. Okay, just close, and then I can select this also as well. So whatever the profile of your walls, it can still generate your connection. Of course, it will not be more than 90 degrees if I'm not wrong. Oh, sorry, it can be, this one can be 90 degrees, more than 90 degrees, so it can be defined. If it's still really too narrow for this part, then it's not possible. There will be an error already. So this is the new feature for the connection. Again, you can just select this element and then you can do some adjustments. Let's say I want to stretch down you can modify directly from your 3D. So these are the new improvement for the reinforcement. Of course, with the wall connection, you can also have a wall property, automatic connection, automatic reinforcement. You can also have this available. So yeah, just create, and then you will have your reinforcement on your walls. Okay, so moving forward, so we talk about the clash detection. So let's say I have a clash here. Maybe I can just show you the attribute for the clash detection. Just clash detection. Do we have some clashing here? Yes, there is. So we have it here. I can say yes. So what I'm saying about the attributes of clash detection. So if I go to this one and then let's just change this. So I can hide my wall. I don't want to see my wall, so I can just select this. Where is it? This one. No, this one. Wall. So I can just hide it. Okay, so now I can easily select my clash. So what am I saying about the clash? If I go to my model attributes, so you can see here, let's say for example, this is just a minor which is tolerable. So you can define this as say soft clash. And then let's say this one will be assigned or say ignore. Then you can see my color will be changed. So it means it is acceptable or it's actually can be adjusted on site or depending on your reason. But from this attribute, you can modify the status of the attribute. And then let's say if it's just soft, and then just say, no, not this one, but this one, not ignore, but let's say fix. And then it also gives you, oh, it should be changing the color. Let's change it. Not soft clash, no clash. So let's say everything is fixed, so it will change to a green color. So this is just clash detection attributes where you can define. And of course, from here, you can have this set of clashes. So you have this, you can define. So I think it's highlighting from this part. So you can see if I hover from this, you can see that the color is defining which you're selecting. Okay, so moving on. So we go now to the mesh welding system. So how to optimize it. So we can go to our small wall here. Also, I have already here. So then I can just create a very fast reinforcement. So I will just go to my, let's say, precast element. I will go to my reinforcement, let's say mesh, this one, and say select this. Or I can just say, oh, I can just say, instead of selecting, I can select the area. So I can select this one, say change to 35. So I will just create a very fast reinforcement. So I just escape, match, define this one. I can have my cross or horizontal bars, and then I have my reinforcement now. So looking from here. Okay, so next is what I'm going to do is from this, I have the mesh welding group. So I can just select this and select everything. So I define this as a mesh and then select my longitudinal bar and then my basic bars. So it means now I created, okay, so it goes to, okay, so this is not a problem. We just remove it because this is for the next fold. So I can just remove this one, and then say this one also. Yeah, so now I'm focused on this one. So how you optimize it from this one, I can label first this one. Let's label the bars here. So this is very interesting. When we go to mesh welding editor, I will just have to select the mesh that I created. And as you can see, I have this interface for the mesh. Now, I can zoom in or zoom out, of course. And then if let's say I want to remove some of the bars here, let's say I want to delete the bars. So This is very efficient because you can easily directly modify your reinforcement here. So let's say I want to remove some of this again. And from this information, you can see here, I can just say, I want it to be like this. I can say close. And as you can see, of course, I need to adjust this so that it's easier for you to see. So as you can see, I have defined this information. Okay, and then if I'm going to modify again, let's change again for the other side. So let's say, because I created some marking on the other side. So let's say this one. Oh, before I forgot. Yes, as you can see here, it changed my marking and group accordingly. So this is very efficient for those who have a mesh welding system on their factory. And of course, for the cages, I have a simple sample here. So let's say a U-bar with this thing. So I can do the same thing, mesh group. Instead of mesh, I can just change this to a cage and say select all, and then select this and this one. So now I define this, and you can see that whenever I press this, it shows me which bars I'm looking at. And then if I will do the same, I will just mark this, name, okay, label this. So I have this label, and then modify my mesh editor, and then select this. So I can make this as how to say it, unfolded shape, or I say folded. So you have these two views. So from this case, I want to adjust my bars again. So just remove it easily. This one, delete. Okay, and then say close. So it automatically change the information here. So this is really usable for those who have mesh welding system. You can easily modify the mesh information of your reinforcement. So you can also do some copy if you want. Let's say for this one, I want to copy, select and then copy. I think you can just do copy here. Oh, yeah, select, define. Yeah, so you can define the information here if you want to copy. Okay, so that's all for my presentation. So we are actually over time, but anyway, as long as I can give you the information, then it's fine with me. If you have questions, I apologize, I cannot answer now because of the timing, but you can just write me an email. So if I share my other screen, okay, so these are the topics that we have discussed. And then, so if you have some questions, you can just scan to connect with me. You can contact me from these numbers and also the email. So you can contact me from this, and then you can scan if you want also because of the QR code, so that you can automatically save it on your phone. Okay, so apologize, I cannot answer the questions, but again, you can just contact me and write me an email if you want. So that's all for today's webinar, and thank you so much for staying and listening to these new features of Allplan 2024 for engineers. Thank you so much, and goodbye.